Hello, hello. So today we're going to talk about simplifying complex numbers. We're also going to talk about adding and subtracting and multiplying complex numbers. So first we need to know what that is. So the best way I can show you what an imaginary number is through an example. So let's try to solve this x squared plus 9 equals 0. Subtract 9 from both sides. You'll be left with x squared equals negative 9. And when you take the square root of a negative number, if you put that in your calculator, you're going to get an error. So the square root of negative 1 is an imaginary number. So I'm going to split that negative 9 up into negative 1 times 9. So we know what the square root of 9 is. It's 3. And now we have a value for the square root of negative 1, which is I. So now I can solve this, but I have this imaginary number I. You don't necessarily need that plus or minus in front of the 3i. It's just habit. I'm used to putting plus or minus when I take the square root. So let's go ahead and look at an example of one of these to try on our own. From here, pause the video, solve this using inverse operations, and remember, you have a value for the square root of a negative 1 now. So when I solve this and I subtract 108 from both sides, and then I divide by 3, I get the square root of negative 36. I split that up into the square root of 36, which is 6, and the square root of negative 1, which is I. Just for fun, let's multiply I times I. So the square root of negative 1 times the square root of negative 1, which is just negative 1 because those radicals cancel out and it just gives us negative 1. I could also write I times I as I squared. So I need to remember that when I see I squared, that it simplifies to negative 1. So let's multiply this I squared times another I. So negative 1 times another square root of negative 1. So this is I to the third. And this I to the third simplifies to give us negative I, because negative 1 times the square root of negative 1 is just negative I. So we're trying to train our brains to learn how to simplify I squared, I to the third, and now I to the fourth. So I to the fourth is I times I times I times I, 4 times, right? So we should be cool with I to the fourth being I squared times I squared. So I'm going to write this as negative 1 times negative 1, which is just 1. So I need to train my brain. When I see I to the fourth, that tells me that that's equal to 1. When I see I squared, that tells me that's equal to negative 1. And when I see I to the third power, that tells me that that's equal to negative I. So to memorize these, I like to think I won, I lost in the middle. So I is the square root of negative 1 is I squared, negative I is I to the third, and 1 is I to the fourth. I won, I lost in the middle. So we need to train our brains. When we see I squared, ew, that needs to be simplified. That's negative 1. When I see the square root of negative 1, ew, that needs to be simplified. That's I. When I see I to the third, ew, that needs to be simplified. That's negative I. And when I see I to the fourth, I need to think, ew, that needs to be simplified to positive 1. So these are all of our shortcuts on how to simplify these I to whatever exponent. So let's go ahead and practice simplifying these. So we're going to look at i's to certain powers, these imaginary numbers raised to different powers, and we're going to simplify them. We're going to change them into something that we see up above in that little thought bubble. So I'm going to take that I to the 13th, and I'm going to split it up into the nearest multiple of 4 that I can find. That's not over 13. So if I look at I to the 13th, the closest multiple of 4 is I to the 12th. Then from here, I to the 12th times I is still I to the 13th. We should be able to agree on that. So any I to a multiple of 4 power, so 4, 8, 12, 16, 20, is going to be equal to 1. So I don't need that I to the 12th anymore. The only thing that's left here is 1 times I. That I to the 12th, because it is a multiple of 4, is equal to 1. So all I have left is 1 times I, which is just I. So we have to train our brains. We have to tell ourselves any I to a multiple of 4 power is equal to 1. So here, same thing. I to the 12th times I to the 3rd is the same as I to the 15th. Any multiple of 4 exponent here on I is equal to 1. So I'm finding that nearest multiple of 4, which here is 12. Okay, that I to the 12th is equal to 1. And then that I to the 3rd is all I have left. Now I to the 3rd, that needs to be simplified. I to the 3rd is equal to negative I. So we have to just train our brains to think differently. Just like when you first started learning about fractions. You don't want to leave a fraction as 3/6. You want to simplify it to 1/2, but that took you time to learn. So the same thing's going to happen here. It's going to take you time to learn. Split that I to the 10th up. I to the 8th times I squared. The nearest multiple of 4 is I to the 8th, which is equal to 1. I to the 2nd, that needs to be simplified. I to the 2nd is -1. So my final simplified answer here is -1. So if I take a look at this last one, I just realized I wrote 2 twice. How embarrassing. You should have 1, 2, 3, 4 there. If I look at I to the 20th, well, I to the 20th, that 20 is already a multiple of 4. So this is just equal to 1. If we're looking at I to any power, where that power is a multiple of 4, so I to the 4th, I to the 8th, I to the 12th, I to the 16th, any multiple of 4 there is going to give me 1. So that's why I to the 20th is 1. I to the 24th would be 1. I to the 28th would be 1. And then whatever's left should be simplified. So I is already simplified. I squared is -1. I to the 3rd is -I. Let's go ahead and try these 4 examples. You're going to hate me. These numbers are big, but try them. Find the multiple of 4 that is closest to that exponent. Split them up and simplify. All right, so for A, my closest multiple of 4 is 124, which leaves me with I squared left over, which is -1. 548 is a multiple of 4, so I to the 548 power is 1. 56 is the closest multiple of 4 to 57, so all that I'm left with is I here. And 36 is the closest multiple of 4 to 39. I'm left with I to the 3rd power. That needs to be simplified to -I. So let's talk about adding and subtracting these complex numbers. So this is just like combining like terms. You're dealing with these like you would if they had variables. If there's a plus sign in the middle, you can just combine those like terms. 2 plus 4 is 6, and 3i minus 5i is -2i. The only important part here is that we want to write those i's at the end. So we'll talk about that in a second. Just go ahead and scratch out that I next to the 14. I don't know what I was thinking. So here we go. Ignore the I there by the 14. So when you look at this minus sign in the middle, you do need to distribute that minus sign. So I'm going to rewrite this. 20 minus 6i minus 14. Scribble out the I. We don't need it. Plus 3i. I'm going to go ahead and combine like terms. So 20, this is where I figured out I made that mistake and I scratched out that I. So 20 minus 14 is 6, and then -6i plus 3i is -3i. So when you normally write polynomials, you put your variable terms first, but when you're writing these complex numbers, you put those i's at the end. Your real numbers go first and your imaginary numbers go second. Those imaginary numbers are like the peasants of numbers. They're not even real. They're imaginary. This is where I asked Mr. Bryson how to spell peasants in the middle of tutoring. So when you are adding, subtracting, multiplying, or dividing, you should always write your real number first and your imaginary numbers last. In a real test or quiz or standardized test, nobody's going to tell you multiply these values together or add these values together. You're going to have to pay attention to the signs in between parentheses or the signs that you see. So here we know that we have to multiply because we don't see a symbol between those sets of parentheses. We're using distributive property or FOIL. So 2 times the first 4 would be 8. 2 times -5i would be -10i. 3i times 4 would be 12i. And then 3i times -5i would be -15i squared. If the arrows for FOIL help you multiply, then use them. I just didn't because my college professor used to make fun of me when I drew arrows on my FOIL. So in the middle here, let's combine like terms. Negative 10i plus 12i is 2i. I should look at this I squared and think, ew, that needs to be simplified. That's negative 1. So negative 15 times negative 1 is going to give us a positive 15. So I'm going to rewrite these whole numbers here. 8 plus 15 in the front. Now we just further combine like terms. 8 plus 15 is going to give me 23. So my final answer is 23 plus 2i. For this next example, again, you want to check in between the sets of parentheses to see if there's any operations there. Because you don't see a plus sign or a minus sign, we know that we need to multiply these. So negative 7 times positive 7 is negative 49. Negative 7 times I is going to give me negative 7i. Negative I times 7 is going to give me another negative 7i. And then negative I times positive I is going to give me negative I squared. Ew, I squared needs to be simplified. Negative 1 is what I squared is equal to. I'm going to simplify the middle there. So negative 7i minus 7i is negative 14i. And this negative 49 plus 1, I also need to simplify, which is going to give me negative 48 minus 14i. Final answer. Real numbers in the front, peasants at the end. So now it's time to try a couple. Notice how I didn't put any directions here. Your directions are just to simplify. So if you need to multiply, multiply. If you need to add, add. If you need to subtract, subtract. You need to figure out what operation is between each set of parentheses. Pause the video here, try it, come back when you're done. This first example, we should have noticed that we are multiplying. Remember that I squared at the end needs to be converted to a negative 1, and 12 plus 16 would give you 28. Notice in B that you had to distribute the negative because you were subtracting, and then you're just combining like terms. Example C, you're just combining like terms here. And the last example, you are multiplying. Notice that the two middle terms cancel out. So this one's kind of like a difference of squares, and you end up with just a whole number at the end because all of your i's cancel out in the middle, and that I squared at the end converts to a negative 1, which leaves you with 9 plus 1, which gives you 10. There's the bell. I gotta go. I have another class coming in. We'll see you next time.